Okay, so now let's talk about two paradigms. We talked about structs and classes. Now let's talk about object-oriented programming versus protocol-oriented programming. Object-oriented programming, of course, is with classes. Protocol-oriented programming is done with structs. Why? Because when you have classes, right? Structs When you have classes, you can inherit. That's basically it. You can inherit and you can use polymorphism. If you don't know what inheritance and polymorphism is, inheritance is when you have one object and it inherits some of its attributes like properties, initializers, and methods from another object. For example, a a Tesla object can inherit its make, model, and price attributes from a car object, you know. Um, Again, structs are done by value, they're copies, so they don't have inheritance. So if you want a type of programming, I guess, that kind of is similar or carries attributes like inheritance and polymorphism, um, what you do is protocol oriented programming. And that means that you have a protocol or a contract that says all these objects have conformed to these rules. They have this protocol, they have this property, they have a model property, they have a make property, they have a price property. And as a result, they're all cars, right? And you can treat them all the same, even though they're different. They're different objects, right? Some might be a Benz object, some might be a Tesla object, some might be a Lamborghini object, but if they all conform to the vehicle protocol, then they can be treated the same and they can have similar attributes that are the same. So we're going to touch on how this works. So you will have a more of a clearer picture. Okay. Let's go ahead and start with enum. Enum, make, lamb, case, Tesla, W. Okay. So we have an enumeration for make or model, case, GALLARDO, HURUCAN, case, SIN, case, EQB. That's a type of Mercedes. Case, AMG, case, AMGT, case, IX, case, IX3, case, I7. So now let's go ahead and let's Let's go ahead and create a car object and show um, how another object can, I guess, inherit attributes from it, right? And I think we've already touched on some of this with regard to initializers. So it doesn't matter if you watch this first and you watch the initializers first. You know, some people will understand it better coming from here. Other people will understand it from watching the initializers video first. But if you need to, go look at that again. So case BMW, right, is the type car, right? And let's go ahead and make a, why I do this? Not case, class. Class car. All cars have what? Talked about this earlier. Bar, make, have what? Make, bar, model, type what? Model. Bar, um, price, type string, right? Now, because it's a class, we have to create an initializer. And you see that Xcode is complaining. So let's go ahead and create the initializers. Init, okay, make, right, make, model, right, model, price is a type string. And then you go in here and you set them self dot make equals make self dot model self dot price. Jesus Christ. Price. Okay. So now, yeah, now everything's working. And you notice here, I'm inheriting from car. Guess what? This has all those attributes. Bar, Beamer equals BMW and everything. Make, model, price, right? Okay, now let's go ahead and make the implementation for this, right? I'm going to create another attribute. Var is EV version. Is this an electric version? Boolean. Now we're going to create a designated initializer. You guys need to go back and check out my video about what constitutes a designated initializer versus a convenience initializer and convenience override. But that's a whole nother thing. So now what I'm going to do right here is I don't have to do all this is EV version. Right? Then I'm going to say self. Switch self. Self that is EV version. equals is EV version. And then I'm going to say super.init. And this is the designated initializer that we had in the beginning that is in the car class. All right. Now set this with the parameters. Make, look, I already know the make. It's always, this BMW is always BMW, right? Model, let's say i7. Price, I don't know how much it costs. 90K. Okay. Okay. And that's just default value. You can always change it later. And so this is an example that now when I say var Beamer equals BMW, right? Model i7. Actually, I can make this BMW. This is should not be. Model should be model. Price should be price, right? Price should be price. So now this price is 80K. Model should be i7. Price should be 95K and is EV version. Let's say now Beamer dot make, of course, is BMW, right? Everything else is set as well. But a lot of this functionality comes from what? The super class, which is car. All right, so now I'm going to show you how to go ahead and this is inheritance and polymorphism. Let's go ahead and look at this using protocol-oriented programming instead of inheritance.